Neuroimaging techniques are a set of non-invasive methods that allow researchers to study the structure and function of the brain in vivo. These techniques provide a unique window into the workings of the brain and have revolutionized our understanding of the brain and its disorders. There are several neuroimaging techniques, each with its own strengths and limitations. Here are the most commonly used techniques: MRI, PET, and EEG. Structural imaging techniques are neuroimaging methods that provide information about the structure of the brain. These techniques allow researchers to visualize the size and shape of different brain regions, as well as to detect anomalies such as tumors, lesions, and changes in brain structure associated with neurological diseases such as dementia and schizophrenia. MRI is the most commonly used structural imaging technique. It provides high-resolution images of the brain structure, allowing researchers to visualize different brain regions and their connections by making use of magnetic field. MRI can be used to detect anomalies such as tumors, lesions, and changes in brain structure associated with neurodegenerative diseases. Diffusion tensor imaging, DTI, is a type of MRI that provides information about the brain's white matter tracts. It measures the diffusion of water molecules in the brain, which can be used to infer the direction and strength of white matter tracts. DTI is particularly useful for studying the connectivity of different brain regions and for detecting anomalies such as white matter lesions. However, each technique has its own strengths and limitations, and the choice of technique depends on the specific questions being asked and the clinical or research context. Here is a comparison of these techniques. Functional imaging techniques are neuroimaging methods that provide information about the brain's function by measuring changes in neuroactivity. These techniques allow researchers to study how different brain regions are activated during specific tasks or cognitive processes. Some of the most commonly used functional imaging techniques are functional magnetic resonance imaging. fMRI is a non-invasive technique that uses MRI to measure changes in blood flow to different regions of the brain, which can be used to infer neuroactivity. It is particularly useful for studying the brain's function and for identifying brain regions involved in specific tasks or cognitive processes. It provides high spatial resolution and allows researchers to identify brain regions involved in specific tasks or cognitive processes. However, it has relatively poor temporal resolution compared to other functional imaging techniques. Positron emission tomography, PET, involves injecting a radioactive tracer into the bloodstream, which is taken up by the brain and emits positrons. The positrons collide with electrons in the brain tissue, producing gamma rays that can be detected by a scanner. PET is particularly useful for studying brain metabolism and neurotransmitter systems. PET has relatively poor spatial resolution but can provide information about a wide range of brain functions. EEG involves placing electrodes on a scalp to measure the electrical activity of the brain. It is particularly useful for studying brain activity on a millisecond time scale and for identifying patterns of neural oscillations associated with specific cognitive processes. EEG has high temporal resolution but relatively poor spatial resolution. In summary, functional imaging techniques have revolutionized our understanding of the brain and have led to a new insight into the nature of cognition and emotion and behavior. These techniques are widely used in both research and clinical settings to diagnose and monitor a variety of neurological and psychiatric disorders. Each of these functional imaging techniques has its own strengths and limitations. fMRI provides high spatial resolution. PET provides information about a wide range of brain functions. and EEG has high temporal resolution.